Today in Minute Physics, we see how fast you need to go to melt. First, we see what the melting point of carbon is, because at a basic level, we are all made of carbon. Then, as a point of reference, we see how hot the leading point of a space shuttle gets when it comes back into the atmosphere. If you divide the melting point of carbon by how hot a spaceship gets, you get 2.1875. A space shuttle re-enters the atmosphere at 30,000 meters per second. So to find out how much faster it would need to go to reach the melting point of carbon, you multiply it by 2.1875. You get 65,625 meters per second. Then you plug that speed into the force drag equation. This equation measures how much drag there is on a certain object. The P equaling the density of air, the V is velocity, the A is area, and the CD is the drag coefficient. The drag coefficient is different for every object. For a space shuttle, it's 4.1. For a person, it's 1.3. Once you do the calculation, you get this giant number. Then you do the same equation, but this time for a person. The differences between a person and the space shuttle is that the area of a person is much smaller than the area of a space shuttle. I calculated the top of my head and the top of my shoulders to be 7.155 meters squared. And the drag coefficient is 1.3 instead of 4.1. Once you do the calculations for the person, you'll get another big number. Then you divide the force drag for the space shuttle by the force drag for a person, and you get 2,097.275. Then you multiply 2,097 by 65,625, which is the velocity that we calculated from the heat. After you multiply these together, you get 137,633,671.9 meters per second, which is also 495,481,218.8 kilometers per hour. And that is how fast you need to go to melt.